Ladies and gentlemen, boys and girls, children of all ages, welcome to the first video of GCSE Grade 7. So we finished our Grade 6 questions that we've been doing, and today we'll be going over the first GCSE Grade 7 question, which is on Surds. If you have any questions related to this one or any other questions at all, please do leave them in the comment section below, and I'll try and get to them as soon as possible. In this video, I'll actually be going over two different types of questions because Surds is one of those topics which requires a bit more thought. So I'll be going over two questions in this video, and hopefully both of them make sense. So the first question is we have to show that 1 over root 2 plus root 2 can be written as root 2 over 3. There are two methods of doing this. In both methods, we have to try and make the denominator into a single fraction because 1 over that fraction will give us the reciprocal of that fraction, and hopefully that reciprocal will be equal to root 2 over 3. However, there's two ways of going about doing this. The first way is to try and rationalize the denominator on the bottom, and the second method requires you to not rationalize the denominator. And we'll go through both of them. So the first way, what I'm going to do is I am going to try and make 1 over root 2 plus root 2 into one singular fraction. All right, so if we have 1 over root 2 plus root 2, and I want to make this into one singular fraction, so what I'm going to do first is I'm going to rationalize the denominator of 1 over root 2. So multiplying both, numerator and denominator by root 2, that will give us root 2 over 2, and we still have the plus root 2 over here. However, we can't add a fraction and a non-fraction, so what we have to do is we have to change the root 2 into something that we can. So in this case, we would make this over 2 as well, and to do that, we'd have to add a 2 at the top here as well. So once we do that, we can add them together, so that would be 3 root 2, because root 2 plus 2 root 2, they have the same denominator, so we know we can add the numerators. That's 3 root 2 all over 2. And now if we go back to the question, it says 1 over root 2 plus root 2, so we know that is the same as 3 root 2 over 2. And when you have 1 over a fraction, all you do is you find the reciprocal. So the reciprocal of 3 root 2 over 2 is 2 over 3 root 2. And now that we have 2 over 3 root 2, we can again rationalize the denominator, multiplying both the numerator and the denominator by root 2. And that would give us 2 root 2 over 3 root 2 times root 2. So root 2 times root 2 is root 2 squared, which is the same as 2. 3 times 2 is 6. And finally, we know that 2 and 6 have a common factor of 2, so we can divide both of them by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So here we've shown that it is indeed equal to root 2 over 3. However, as we can see, this was quite a long method, a long way of going about doing it. In this specific case, we don't have to rationalize the denominator, and I'll show you that on the right-hand side. So if we didn't want to rationalize the denominator to start off with, then we would still have the 1 over root 2 plus our root 2. However, I'm going to leave the 1 over root 2 as it is, and then the root 2 that follows, the plus root 2, I'm going to make that have the same denominator. The same denominator, so I want to put that over root 2 as well, so I can add the numerators. But if I'm putting it over root 2, we have to multiply the numerator by root 2 as well. So that would now be equal to 1 over root 2 plus root 2 times root 2 is 2. And it's all over root 2. Now they have the same denominator, which means you can add them together. 1 plus 2 is 3. That's 3 over root 2. The original question says 1 over all of that. So the original question was 1 over 3 over root 2. And again, when we do 1 over a fraction, we just find the reciprocal. So we just swap the denominator and the numerator around. 3 over root 2, we swap them around, we get root 2 over 3, and here we have the answer again. And here we've shown that it can be written as root 2 over 3, but in a lot of fewer steps compared to the method on the left. All right, so the answer to this question can be either the method on the right or the method on the left, but either or would give us the correct answer. All right, just to go over it quickly again, on the left, we try to rationalize the fractions on the denominator. As we did that, we found out it to be 3 root 2 over 2. Then we put it back into the original question, which was 1 over what we had just created, which was 3 root 2 over 2, which gave us 2 over 3 root 2. Multiplying both denominators and numerator by root 2 gave us 2 root 2 over 6. And finally, the 2 and the 6 cancelled out to give us root 2 over 3. On the right, we chose not to rationalize the fractions in the denominator and just chose to add 1 over root 2 and root 2 together by giving root 2 the same denominator. That gave us 1 over root 2 plus 2 root 2, creating 3 over root 2. And when you find the reciprocal of that, you get root 2 over 3. And that was the answer to the first question. Now, the second question is a bit different. The second question is asking us to simplify fully 2a plus root b all squared. And the way this is different is because we're using a bit of algebra instead of actual numbers. Let's see how that works. All right. So our question is 2a plus the square root of b all squared. We know that is equivalent to, well, square means to multiply something by itself. So we will have our double brackets. There we go. And now we're going to do the same thing we normally do. So that is our how to expand up brackets. I have actually gone over this before when I was expanding triple brackets, so please make sure to check out that video if you don't understand how to do this. So firstly, we have our 2a multiplied by our 2a, and that would give us 4a squared. Next, we have our 2a and our positive root b, which would give us 2a root b. Next, we have our root b multiplied by our 2a, which again would give us 2a root b. We write it like this because normally we want them to be in alphabetical order. Also, we want the numbers to appear before. So instead of writing root b 2a, I wrote 2a root b. And finally, we have our root b multiplied to our root b, and that would give us b. And I've written them in these specific colors because then I know exactly what I need to add up together. So all my greens are my a squareds. There is only one number which has an a squared on it. Then we have our 2a root b and 2a root b, and you add them together to get 4a root b. And finally, we have 1b on its own. So now we've simplified fully 2a plus root b all squared. And that gives us 4a squared plus 4a root b plus b. All right. I hope these two examples have made sense. If you have any questions on these, please do leave them in the comment section below. If you have any other questions about any other topics, we are now in grade 7 territory, so please do ask harder questions if you would like to, and hopefully I'll be able to answer them as soon as possible. All right. Thank you for watching and stay safe.